example comes out of section 5.1, graphing sine and cosine functions. In this example, we're going to take a look at the graphs of y equals cos x in degrees and radians and the graph of y equals sine x in degrees and radians. These will be relatively rough jobs without a ruler, but y equals cos x, we'll make two graphs. In degrees, we'll go from negative 360 up to positive 360 just so we can see two full cycles of the graph, and we'll make sure we have a graph that goes up to positive 1 down to negative 1. In radians, the only difference is going to be that our x window, or x max and x min, will have in radians, so negative 2 pi to positive 2 pi. Now, cosine of 0 is 1. This graph has a period of 360 degrees, so it's going to be back at 1 after 360 degrees. Halfway in between at 180 is going to be at its minimum. Halfway between max and min, it's at 0. So at 90 and at 270, it has zeros. So to graph one full cycle of cosine, I basically connect those dots and end up with something like that. If I head in the left negative direction, I'll just have a repeat of the exact same thing. And so I have a function that looks like that. It's even symmetrical about the y-axis, which means it's an even function, and it is periodic, cyclic, shares a lot of characteristics that the sine graph had. In radians, I will have the exact same picture, except for, obviously, my x scale needs to be done in radians, not in degrees. But the shape of this graph still is this sinusoidal wave. Has a period now of 2 pi, not of 360, but the shape of it, the max and the min, all the same. So we have a graph that looks like that. Now, for the sine graph, sine function, we did a fairly good job of drawing this in a previous example. If I do the same thing, maximum of 1, minimum negative 1, going up to 360 and down to negative 360, this one goes through the origin. It will be back at the origin after 360 degrees. It has a maximum of 1. It actually has another x-intercept at 180. And so you have a graph that goes up, back down, down, back up for one full cycle. Looks very similar to the one above, especially once you start to draw the left side of it. And it goes through something roughly like that. In radians, it won't look different other than I have to label my x-axis differently. 2 pi, negative 2 pi, up to positive 1, down to negative 1. So we're going to up, back down, down, back up, in both directions, and we have a sinusoidal wave that looks like that. So, some characteristics that these two things both have. Period, in degrees, 360 degrees. In radians, 2 pi radians. They both have a maximum equal to 1 and a minimum equal to negative 1, meaning their range is exactly the same. The range is all values of y that fall between and including negative 1 and positive 1. Any real number in there will be in your range. Their domain is all real numbers. X, where x is an element of all real numbers. Their amplitude, related to their max and their min, their amplitude is 1. So, really, if you look at it closely, it looks like you could take a cosine graph and move it a little bit to the right or left, and you could turn it into a sine graph. And that's true, and that's actually something we will look at when we get to transformations of sine and cosine functions a little bit later on.